Yeah, hello, good morning everyone. This is Asan Raju, Assistant Professor in Mechanical Engineering Department related to Chipper Engineering College. Today we are here to discuss regarding the mechatronics, which is a subject in final year mechanical. Yeah, going into the mechatronics, there's a synergetic combination of both mechanical and electronics, which will be controlled and operated under the guidance of the computer-based systems, which we will be calling it as an control systems, naturally which will be utilized in the electronics department. So the combination of this, both mechanical actuators indeed to operate with respect to the electronic gadgets, is nothing but the mechatronic subsystem, which is used widely in the present day's technology, where the manual process cannot be involved and do the work. Yeah, the basic definition of mechatronics itself specifies that it's a combine of mecha from mechanics and tronics from electronics. Actually, the word of mecha has been arrived from Japanese language, and electronics, which will be supporting the mechanical actuators to be worked in a perfect manner, that is actuating regarding the coordination basis towards the positive x, negative x, or positive y, negative y, simultaneously towards the positive z and negative z axis, which we will be calling as prismatic joints in the case of the robots, which will be utilized on behalf of the manual process. Here, coming to the mechatronics, it specifies the technology what will be utilized indeed to work and give the directions for operating the robotics or robots, particularly in n number of fields, basically the industrial fields, medical fields, etc. Moving on to the different kinds of definitions given by different authors, we'll be seeing roughly this definition. Mechatronics is a synergetic integration of sensors, actuators, signal conditioning, power electronics, decision and control of the algorithms. Yeah, we have already seen that, discussed previously, that mechatronics is a combination of both mechanical, electrical, which will be organizing or controlled under the guidance of the IT-based systems, nothing but the computer science or else the information technology. Yeah, here it clearly specifies that mechatronics is a synergistic combination of sensors, actuators, signal conditioning. These are the components related to the electric conditioners, electric conditional monitoring devices, and these decision and controlling algorithms, programming, and all will be related to the computer science or IT department. And upon a combination of this, will give the feedback to the control system and will actuate the different types of actuators in the mechanical mode. So these actuators commence the work in the form of action, which will progress in the real-time basis. Here we have the another one more definition regarding the mechatronics. Let's see it. It is a synergetic use of precision engineering, control theory, computer science, and sensor and actuator technology to design improved products and process. So basically, this definition bestly suited for industrial fields. It's a combination of engineering. Engineering is nothing but the combination of different types of materials which are used for processing different kinds of actions. And control theory. So control theory here specifies that in what way that we are controlling the components indeed to commence the working processes. Next, coming to the computer science and sensors. So sensors basically we know that is a feedback device which will be utilizing in the components. Actually, this sensor will give the signal as a feedback to the controller, and that controller will categorize whether the processing is being done with a mechanical components in a correct manner or not. Here, the computer science department will program the overall actions that need to be performed by the actuators. There is nothing but the computer instructions that are being given to the physical parameters or mechanical components to be worked in a perfect way. And this definition best related to the industrial fields, that is carrying the material from one place to another place, or pick and place kind of robotic working and continuous progress of working that is to be done with a similar kind of geometrical constraints. Next, we have another one more definition regarding it. It's a statement given by W. Bolton, which is well suited for the robotic technology as well as the mechatronics, electronics, control systems, and mechanical engineering. A field of study involving the analysis, design, synthesis, and selection of systems that combine electronics and mechanical components with motor control and microprocessors. Application of complex decision making to the operation of physical systems. So here it leads to the two different kinds of components. Those are mechanical components, nothing but different kinds of elements that are situated to be worked for different kinds of process. For example, in a workshop scenario, milling process, drilling process, reaming, boring, and sizing process, etc. And you need to commence that particular processes, the program need to be given. That program will be written in the different kinds of languages that will be getting suggested basically on the support of C language basis, and different commands modes need to be entered, that is moving of a particular link to an towards the x-axis direction, towards the y-axis direction, towards the z-axis direction, or else towards the movement of orientations towards the clockwise direction, orientation towards the counterclockwise direction, and simultaneously the on the rotational basis it will be has to be rotated towards the 30 degrees towards from x to the y in an ordinate, or else a shifting of an coordinates from xy to xy plane to the yz plane, depending upon the theta value, that you are providing. Here microprocessor, here we have a device, electronic device, that is microprocessor. It's an program storing device that will be utilizing for continuous sequence of instructions giving to the mechanical components, and but executing the instructions that are programmed into the microprocessor. So basically, this is a microprocessor is an electronic component which will store the program for an similar kind of operations need to be performed in the industrial sector. All right. Yeah, there will and this and furthermore additional parameters can be utilized for chaining of the programs, and the programs can be rewritten in the microprocessor, or else simultaneously in this queuing process after completion of one program, or else when the execution has been given to an actuating system, simultaneously in the microprocessor existing program can be modified with respect to the next categorization of operation. These and all can be monitored by utilizing the control systems. And basically, the programming is a major factor for it, indeed, to change the set of instructions. It clearly specifies, and we'll be learning how the programming is giving into the systematic view, how it is being executed, whether the processing actions are being performed in an precise manner or not, and the feedback carries towards the comparator, and the comparator measures and give the analysis to the processor, and then to the controller will manipulate the compensation activity for getting the work done which was unfinished in the previous process. So without the involvement of the human being, the inspection activity will be getting performed after the completion of the entire this process, periodical process, and the packing section will be getting considered in the industrial basis and will be sent into the warehouse. Depending upon the order basis, it will be shaped to the different marketing sectors. Yeah, now we'll be going into the deep of this mechatronics. So here it is the perfect definition for the mechatronics. It's a synergetic integration of sensors, actuators, signal conditioning, power electronics, decision and control algorithms, and computer hardware or software to manage complexity, uncertainty, and communication in engineering systems. So, what we call engineering systems, communication in engineering systems. So latest technology utilization and commencement of the work within the less time than the existing time leads to an perfect identification of new thing. That is an innovation. So indeed to happen there such kinds of innovations, these and all the parameters required and have to be done the work in a real-time basis. Perfect. Before getting done in a real-time basis, there will be a simulation activity that need to be performed for calculating the better accuracy for the work to be commenced. So hence here the electronic components will carry the perfect signals from the control system to the different devices. It need to work in an exact manner that the instructions will be carried to the actuators for an perfect operating conditions. And hence these feedback components will give the feedback frequently to the controller for an perfect operation as well. And hence, according to the W.B. Bolton and Japanese authors, and towards the ISO standards, and basically in the mechanical will be following the ASME standards, that is American Society of Mechanical Engineering Standards, and even AISTM, the different kinds of materials that are being tested related to the American standards. By one segregation of this all data, you have concluded a basic definition, that is mechatronics. Yeah, here it is disciplinary foundations of mechatronics. So, what are the different kinds of subsystems that are controlled by the major mechatronic system? So, we already know that mechatronics is a combination of both mechanical electronics and informatics under the nothing but the programming nature, that is IT based systems. Here what we will be calling as an information systems. So mechanical systems we have been aware of, electronic systems we have been aware of, computer systems that we have been aware of, and informatics systems. There is a communication channels need to be maintained, different kinds of hardware sessions utilized, different kinds of software sessions utilized. There's a major important role that is interrelated to the mechatronics subsystem. Each and every component has been interrelated with respect to the mechatronic system with an bus interface unit. Bus interface unit. Hence, this basic control system will be existing at this mechatronics control system. And this will give the permanent signals towards the subsystems indeed to get identified as an perfect managing activity. Here we are having different subsystem levels, that is multidisciplinary, cross-disciplinary, interdisciplinary. So multidisciplinary in the sense it's an additive process of bringing multiple disciplines to bear on a problem. For example, the company is getting manufactured only 10 different nails in a single shot of operating machinery. It need to be operated 10 plus additionally 10 more nails of different sizes. So previously we were having a headstock of 2 mm of diameter, and recently we may have the 5 mm of the diameter, or else 2 centimeters, or else the 5 centimeters of the diameter. And next, a length with respect to a cross threading will be related to the 2 mm in between one thread to the another thread. That's a circular mold. So simultaneously, indeed to manufacture only one shot at 10 different components simultaneous in the same simultaneous operations, we'll be getting 20 different components within two different batch productions. That is changing in its dimensions. That's a multidisciplinary. For that, the IT systems need to be grabbed the another kind of program which has to be merged to the existing program and to work in a single constituency mode. And based upon that, and that will be progress, that program will be progressed from the informatics system to the control system, and this control system need to be grabbed the different computer systems to be monitored whether the actions are being perfectly working or not, and the working actions will help be carried by the electrical components to the mechanical systems to be worked in a perfect way. There is an output way. Here we'll be calling another one more supplementary foundation, that is cross-disciplinary. In this process, one discipline is examined from the perfect of another discipline. So here is another constituency. Whether the manufactured product is valid or not, you need to check it before itself. There will be a simulation process. If the simulation process has been commenced well, then only the real-time basis of work will be getting examined, or else the processed. Here, cross-disciplinary in the sense the production rate will be in an intermediate ratio. That is, after completing of one batch production, then only it will be moving for manufacturing of the secondary batch production of any kind of components. Or else indeed, even to change the geometrical constraints of a single component, after completing of the existing components, only they will be proceeding for the next component. Here, the cross-disciplinary will be specifying that constituency in the mechatronics discipline. Next it is interdisciplinary components. It's an interactive process involving two or more disciplines simultaneously to bear on a problem. So interdisciplinary in the sense that here there are two different components, intradisciplinary and interdisciplinary. Intra, I-N-T-R-A. So intra in the sense within the mechanical substituency or within the boundary conditions or within the system. So interdisciplinary in the sense with respect to one system and another system. So here we are having the interrelations with respect to two different systems. So whatever the actions that have been given from the another system also will be progressed by this system, and simultaneously this system also can be processed its actions in the real-time basis. So hence two or even more actions also can be performed. Let's consider one of the best example in interdisciplinary concept. That is, here one laptop has been connected to a printer, another one more system has been connected to a printer, and softwares will be getting changed. Word copy and PDF copy and even PowerPoint copy. So three different softwares. From three different softwares, by utilizing one electrical device that is connected to the printer and to the system, I have given the three different prints at a time. So the printer is an one device that is accepting the PDF copy, the Word copy, and even the PowerPoint presentation as well. And it's not only accepting from one system. If the electronic component, that is bus interface unit, that has been connected from the same printer to the another system, not for the laptop to the system, simultaneously the Word or PDF copy that have been given, the printing from that particular system also will be accepted by that printer. So there is two different systems are giving the instructions to a single printer, and it is being getting job done. That is an interdisciplinary concept. Moving on to the next.